Hi guys, so in this video we will be solving this problem sliding puzzle. Okay, so the problem says that we will be given a 2 cross 3 grid. Yeah, we will always be given a 2 cross 3 grid of some numbers 1 2 3 4 0 5. This is our initial state and we have to achieve a final state. Our final state is this 1 2 3 4 5 0. This is our final state. Okay, what we are allowed to do, previous, yeah, so what we are allowed to do is that we can swap the position of the 0 with the adjacent cells. Like if we are 0 is present over here, so 0 can be swapped with the adjacent cells like left, right, top and bottom cells. So if we swap the positions, we'll get something like this: 1 1 0 3 4 2 5. Other option could be 1 2 3 0 4 5 and so on. We can apply the swapping again. When we reached at this particular configuration, we can again swap the position of the 0, so we can move to some place like 0 1 3 4 2 5. This is one configuration we can attain. Another one could be we can swap 0 with the 3, so we will get like something like this: 1 3 0 4 2 5 and so on. We can perform this swapping of 0 and we have to attain this final configuration in the minimum number of swaps possible. Okay, so what we have to tell is the minimum number of swaps to attain the final configuration. So I guess the problem statement would have been clear to you guys till now. Now let's move on to the approach how we can solve this problem. Okay, so initially we were given, like, let's see the problem what we were given: 1 2 3 4 0 5. 1 2 3 4 0 5. So what we will do is that we will try all the possible swappings, like what we can do with the 0. So the options are what? I can swap with the left character. So what I will get: 1 2 3 0 4 and 5. Other option could be what? I can swap 0 with what? The top character. So what I will get: 1 0 3 4 2 and 5. Another option could be what? I can swap this 0 with the right character. So what I will get: 1 2 3 4 1 2 3 4 5 and 0. So initially when I was over here, I was at level 0, like I had not performed any swaps till now. Now at this particular location, I was like I could perform three particular swaps. Like I could perform swap with the top character or left character or the right character, but each time I will not be able to perform the three swaps. Like think of this particular case: if 0 would have been present over here, then I could swap only with the bottom character or the right character. So the number of swaps are different each time, like allowed swaps which are allowed will be different each time. So at this particular moment, 3 swaps were allowed, so I performed the 3 swaps, and these are the configurations which I got after performing 3 swaps. So now currently my level will increase by 1. 1 indicates what? I have performed 1 swap. Okay, now what I will check: this is my configuration. Is it same as my final, like the one desired configuration? If I check, no, these are not the same. So what does it mean? I will perform more swaps. Whatever the available options I have, I'll perform more swaps. So what I can do from over here, I can swap this 0 with this 4. What I will get: 1 2 3 4 0 5. Now if we look clearly, this and this is what? These represents both the same state. So what we are again going back to the initial state. So we need to maintain some visited kind of thing so that we do not get into the loop of doing the same task again and again. So we will make a visited array, or not array, we will make some visited thing which will help us to detect that we do not get back doing the same thing again and again. So we will not perform this particular swap. Okay, so our 0 I will not perform with the 4. We can perform swap with the top character. So if we perform the swap with the top character, what we will get? We will get something 0 0 1 2 3 4 and 5. This was the only one option available over here. Now if we look, now we move to the next configuration. We check it with the final configuration. Is it same? No, it is not same. So what we will do, we will again apply the configurations, means all the possible moves which we have currently. So this 0 can be swapped with the left character, right, and the bottom character. So if we let's do one by one. Let's do with the left first. So what we will get 0, 1, 3, 4, 2 and 5. Okay, this is one configuration. Another could be when we swap with the bottom character, but when we swap with the bottom character, we will get the same, or we will get back to the original state. What will happen is that we will get this state 1, 2, 3, 4, 0 and 5, and this is same as the initial state, so we will not do this again. Okay, since we have already visited this state earlier in the past, so we will not get back to the same state. Okay, so we will not make this swap. And now 0, this 0 can be swapped with the right character. So what we will get 1, 1, 3, 0, 4, 2 and 5. This is another option. Now we move on to the next configuration. First we will check whether it is same as our final configuration. So if we check, yes, it is same as our final configuration. So what we will do, we will check the current level, the level at which we have got this particular configuration. So level equals to 1. Level equals to 1 indicates that we have performed one swapping to get this particular, means to get the final result. So our answer will be what? Answer will be equal to level. That is, we require only one swapping to reach to the final configuration, and that is true also. If we check over here, if we swap 0 and 5, what we will get? 1, 2, 3, 4, 5, 0, and it is our final configuration. Okay, so this is what we are going to do. So we will be applying the BFS over here. We will be applying all the possible moves which our zero index have, and we will generate the new configurations. In the new configurations, we will check if it is equal to our the final configuration. If it is, then we will simply return the level. Otherwise, we will generate the new configurations, and as we do in BFS, we will keep track of the configurations which we have already generated. Like we will maintain a visited kind of thing, so that we'll be able to keep track of the already generated states. Okay, so the idea would have been clear. Now let's see how are we means going to keep track of these visited states. Like this is the tricky part in this particular question. Like we can do something like this. We will store each configuration of this 2 cross 3 array. Like first time what we got something like this 1, 0, 3, 4, 2, 5. We will maintain something like we will store multiple 2D arrays, and each time we will check whether we have already got such a configuration earlier in the past. But this is not a feasible or a very good option. Like we will not be doing this. What we will be doing is that we can store the configurations as strings. What do I mean by it? Let's me explain that. Let me index this. Okay, so what this is, what 0 index, 1 index, 0, 1, 2, 3, 4 and 5, and I will store my initial state as initial string. Okay, and my initial string will be what? Initial string will be 1, 2, 3, 4, 0, 5. Okay, now I will store my final string, that is my result, the final configuration which I desired as 1, 2, 3, 4, 5, 0. Okay, now I will simply check whether my current string generated is same as the final string or not. But like there is an issue in this. Like if we store the matrix, then we know that if we are at particular location, what are the possible moves. We know that we can go 1 unit upward, 1 unit downward, 1 unit left and 1 unit rightward directions, and we will check if it is a valid configuration. Then we will check, then we will simply swap. But how we will do this in if we store it in a string? So what we are going to do is that we will maintain a index array. Means we will store a two-dimensional array. Like if we are at index 0, index 0 means index 0 element can swap with what? Index 3 and index 1 element. Index 2 element, index 2, where is index 2? This is index 2. So this element can swap with what? Index 1 and index 5. Similarly, we can store it in an array. Like what we will do, we will make an two-dimensional array. We will make an array where we will store index 0 element can swap with what? Index 3 element and index 1 element. Okay, index 1 element can swap with index 0, index 2 and index 4. So index 0, index 2 and index 4. Index 2 element can swap with index 1 and index 5. Okay, index 3 element can swap with index 0 and index 4. So index 0, index 4. Index 4 element can swap with index 3 and index 5. Index 3 and index 5. And index 5 element can swap with index 4 and index 2. Index 4 and index 2. So we can use this array to find how to perform the swapping. Okay, So let's keep it side. It will be helpful to us. Let's re-verify it whether it is correct or not. Index 0 can swap with 3 and 1, correct. 1 can swap with 0, 2 and 4, that is correct. 2 can swap with 1 and 5, that is correct. 3 can swap with 0 and 4, that is correct. 4 can swap with 3, 5 and 1, that is 4 can swap with 3, 5 and 1. So 3, 5 and 1, and 5 can swap with 4 and 2. Okay, so this we can use for swapping, for performing the swap. This we can use. Okay, so now let's see how we will be performing this algorithm after once we, if we are storing it as string. Okay, so what we will do is that we will maintain an initial string. So we'll traverse this matrix and we'll maintain an initial string. So our initial string will be what? Initial string will be 1 2 3 4 0 5. We made an initial string. Our final string will be what? That is target string. Final or target string will be what? 1 2 3 4 5 0. So this is our desired string. So we know that we can swap the zero, means zero element. So I will find the index of the zero element. Index of zero element is what? Index of zero element is 0 1 2 3 4. Index is 4. So we will check in our array. If our index is 4, then which elements can we swap with? So this is for 0, this is for 1, this is for 2, this is for 3, and this is for 4. So if our index is 4, then we can swap with 3, 5 and 1. So let's do that. So if we swap with third element, what we will get? Let me write the index over here also. 0 1 2 3 4 and 5. 4 and 5. So we can swap with third element. So if we swap with third element, we will get what? 1 2 3 0 4 5. This is one configuration we will get. Another we can swap with fifth element. So what we will get? 1 2 3 4 5 0. Another one we can swap with first element. So we will get 1 0 3 4 2 5. Okay, now we will, so this was initially we were at level 1, that is we have not performed any swapping till now. Now we are at level 1, that is we have performed one swapping till now. Now one by one we will check the characters, means check the strings. If the string is already visited in past, like we will store a visited something, kind of visited something, and we will store that 1 2 3 4 0 5 is already visited in past. Now we will check 1 2 3 0 4 5, is it visited, not visited? So we will mark it as visited. Okay, so let's mark it over here only, that so it is visited. Now we will check it if it is equal to our target string 1 2 3 4 5 0. No, it is not equal to our target string. So what we will do, we will generate again the configurations from this string. So here 0 is at what? 0 1 2 3, third location. So if we are at third location, what are the possible moves? We can swap with 0 character and 4 character. So if we swap with 0 character, what we will get? 0 2 3 1 4 5. And if we swap with 4, then what we will get? If we swap with 4 0 1 2 3 4, we will get 1 2 3 4 0 and 5. Okay, and if we are seeing that this is already visited in past, so we will not visit this particular case. Okay, so let me erase this one. So we are not going to visit this one. Okay, so work is done for this particular string. Now we'll move on to the next string. Now we will check the position of 0. First we will mark it as visited, like if it is already, it was already visited in past. No, it was not visited, so mark it as visited. Okay, now let's check the position of 0 character. 0 is at index 1 2 3 0 1 2 3 4 5. So if we are at 5 4 and 2, we can swap with 0 1 2 3 4. This is for 5, we can swap with 4 and 2. So if we swap with fourth character, so what we will get? 1 2 3 4 0 5, and we are seeing that it is already visited, so we are not going to visit this state again. Okay, so let's erase this string. Another option which we can do is we can swap with the second character. So if we swap with the second character, what we will get? 1 2 0 4 5 3. Okay, so this particular state. Okay, so this is not visited in past, so we can keep it. Now let's move on to the next state. Is it visited already in past? No, it is not visited, so we will mark it as visited. Now we will check if it is equal to our target string. So if we check, yes, it is visited to our target string. So that means we have find the final configuration. And if we check current level, our current level is 1. So what does it means? It means that we require only one swapping to reach this particular state. So our answer will be 1. Okay. So now let's see what we have done. How we are going to means. I guess the algorithm would have been clear, but let's once again recapitulate it. So what we will do, we will first traverse the matrix and make initial string and final string. Initial string plus, we will make the initial string plus final string, and we will apply the BFS technique. Apply BFS and we will generate new strings one by one. Let's write that. We are going to apply BFS, generate new strings like the possible string, and we will check with the target element. If it is equals, then if equals, then we'll simply return the current level, whatever is our current level. If our BFS is exhausted, then finally we'll return -1, which indicates that this particular state cannot be reached. Okay, and we have how to apply BFS. I guess you guys already know what we do. For that, remove mark star add algorithm. I guess you guys already know. And for visited, maintaining the visited, we will convert into string. Okay, so I guess the algorithm would have been clear. So now let's try to code this problem and let's see how whether it is working properly or not. Okay, yeah, so now let's try to code this problem. Okay, so we are given this sliding puzzle function. So as discussed, we will be first making our two strings, that is initial string and our target string. So let's make initial string and target string. So what we will do, for integer I equals to 0, I is less than vector 1 dot size plus I. For integer j equals to 0, j is less than vector 1 of 0 dot size plus j. What we will do, s1 equals to s1 plus 2 string vector 1 of I comma j. Okay. Like, let's discuss it once. What was discussed, what we were doing, that we were first making our initial and target strings by traversing the matrix. After that, what we were doing, we were simply applying the BFS on it, and at each stage what we were checking that whether our current removed element, if it is equals to target or not. If it is equals to target, then we were simply returning the level. If it was not equal to target, then what we were doing, checking all possibilities. We were checking all the possibilities by swapping character. So this is what we were doing, and finally we were returning -1 if the BFS was exhausted. That means there was no possible way in which we can reach the configuration. Okay, so we have made our initial string. Let's make our target string target equals to what, 1 2 3 4 5 0. So this is our target string. Now for BFS we need a queue. So queue of string q, we will add our initial q dot add initial. Okay, we will need a visited also. So for that, let's make an unordered map. We can use unordered set also for this, but let's for now use unordered map. So unordered map of, we'll need string and boolean. Let's name it as map1. Okay, we will do it while q dot, like in BFS, whatever we do, while q dot size is greater than 0. Let's calculate the size of q dot size, while size minus, what we do, we remove the element. So string removed element equals to what, q dot front. Okay, after that q dot pop, we will remove this element also. First what we check, if this element, if it is equals to target. If it is equals to target, then simply return level. We have not made the variable level over here, so integer level equals to 0. Let's mark initial string as visited also. Initial equals to true, where string and boolean represents whether it is visited or not. So initial, okay. Otherwise, if it is not visited, then what we will do, we will add it, means all the possibilities. And initially the matrix is given to us in this form 1 2 3 4 5 0, but what we are storing, we are storing it as string so that we can use the visited array. So for the possible combinations, what we have made, we had made a direction array using which we could find the possible combination. Like we have made it something like this: 1 2 1, as discussed, 0 1 2 3 4 5. We know that if 0 is at this location 5, then to which places can we swap. So we can see over here that we can so if we are at 0, then we can swap with index 1 and 3, and if we are at index 1, then we can swap at 0 2 and 4. If we are at index 2, then we can swap at 1 and 5. If we are at index 3, we can swap at 0 and 4. If we are at index 4, we can swap at 1 3 and 5, and if we are at index 5, we can swap at 2 and 4. So this we have already calculated, but still we need it over here, so we recalculated it. So for that, let's make a direction array. Let's name vector of integer directions equals to 1 3, okay, then 0 0 2 and 4, then 1 and 5 then 0 and 4, then 1 and 3 and 5, then 2 and 4. Okay, now what we were doing, we were first, like if we have any string over here, when we were having any string 1 2 3 4 0 5, so we were calculating the index of 0, like 5 over here. Then we were checking in this array what are the possible places where we can swap for 5, like 1 2 3 4 0 5. We see we can swap with first character. So one option is what, 1 0 3 4 2 5. We can swap with third character, and so on. We were generating the new configuration. So we'll do the same over here also. So let's do it. So for first, let's calculate the index. So I equals to 0, I is less than removed element dot size. What we will do, plus I. We will check if removed element of I is double equals to 0. That means we have found the index. So index equals to I, and we will simply break it. Okay, let's make a variable index. Teacher index equals to -1. Now we will need an array. So let's vector of integer array equals to directions of index. Now we will travel in this index for integer I equals to 0. I is less than array dot size plus I. Let's make a new string. New string equal to what, removed string. Now if we have the string 1 2 3 4 5 0, so if we check that we can swap for, if we are at the 5th index, so we can swap with what, second character and 4 character. So whatever is index over here, we can swap with those characters and generate the new strings. So this is what we were doing. So we'll do the same over here now in code. So what we will do, we will swap new string of index, that is the position of the 0th character, and new string of array of I, that is whatever is stored in the current array index, array of I. Whatever is stored in array of I, first 2 is stored, so it will be new string of 2. If 4, then new string of 4. So array of I. Okay, after that what we do, we check if it was already visited or not. Like, so we will check if map1 dot find this new string is not equals to map1 dot end, that means it is already visited earlier. Then we will simply skip this one. We will mark continue. Otherwise what we will do, we will mark map1 of new string equals to true, and we will add it in the queue also. So queue dot push new string, and each time we are incrementing our value of level also. And finally, if this BFS is exhausted, then what we will do, we will simply return -1. That means there is no solution. So let's check whether we have done everything or not. We have made initial strings and we have made the final target string. We have made started the BFS, added BFS. We have visited. We have level. We have marked the initial string as visited. Also direction array. We are removing the elements. We are checking if it is equals to target. Then we will simply return. Otherwise, we are finding all the possible configurations and adding it also, incrementing the level. Finally, we are returning -1 if the BFS is exhausted. Okay, let's try to run this code. Let's see if there are some errors. So it is passing. So there are some errors. Okay, so S1 was not declared in this code. We have some typing mistake. So it is initial initial it will be initial. Yeah, let's see if there are some more errors. Q dot add initial. Yeah, it is due to that only. Now let's try to run it. Initial plus 2 string of vector 1 of I comma j. Initial is there a spelling mistake? Okay, it is a spelling mistake. Initial it was spelling mistake. You dot add initial. Yeah, this spelling mistake is over here also in line 12, somewhere line 12 initial. Yeah, it is correct now. You dot add initial. Now let's try to run it. I think it was due to spelling mistake. Yeah, there this spelling mistake, where it is line number 12, there is a spelling mistake. Q dot add initial. Yeah, this is correct. Q dot add initial. Okay, this is correct. Initial. Let's do one thing. Let's copy paste it. Control C. Control V. Control V. Control V. Control V. Okay. Now let's try to run it. Oh, it is due to this Q. It will be Q dot push, not add. So we are getting correct answer. Let's try to submit it. Let's see if it is passing all test cases or not. So it is passing. So the solution is correct. So I hope you guys would have enjoyed the solution.